Okay, Matthew, can you just keep going on this and expand the question?
Okay, yeah. Okay, so we are given that we have an ABC triangle ABC with AB of length 50 and AC of length 10, and that triangle ABC has an area of 120, and then D and E are midpoints of AB and AC respectively, and then we have an angle bisector AG, and then we have points F where it intersects ED. And it wants us to find the area of FDBG, the quadrilateral. So one thing that we can note is that we can see that since we can see that triangle ADE is going to be similar to triangle ABC. And the reason we get that is equal is because since this is just the midpoint, that means this side is going to have length 25 and this side is going to have length 10. And then triangles ADE and triangles ABC all share the same angle, and then they both share the same side ratios. So they're going to be equal. And then, so that means triangle ADE, since each side length is half of ABC, that means the area, if the area of this is just going to be 1/2 squared of triangle ABC, So then, which is just equal to 30. And then, so what I did is I denoted, I denoted the area AEF as X, and then the area CEFG as Y. And then since AG is an angle bisector, by the angle bisector theorem, that means EF over FD should equal 5/25, and then which is also equal to 10/50, which is just equal to CG over GB. And this can be very useful because now that we can write things in terms of X and Y, because the area of, so let's say, for example, we wanted to compare the ratio of the area of triangle ACG over the triangle of AGB. Since it's an angle bisector, that means just the ratio of their sides, CG over GB, because they will both share the same height. So then, in essence, the ratio of their areas will just be the ratio of their side lengths. So now that we know this principle, that means this is 5x, and then this is 5y. So then now that we saw that ADE is equal to 30, that means the area of CED, CEDB, if the quadrilateral CDEB is just equal to 120 minus 30, which is equal to y plus 5y. So then that simplifies to 6y is equal to 90. And then after some simplifying, y equals 15. And then since we want to find the area of quadrilateral FDBG, that is just equal to 5y, which is just equal to 75.
Very good. Any question about it? William, do you get it?
Yeah.
So which part stops you?
Oh, it basically was trying to use the different silence compared to the area ratios.
Well, the midpoint give you the the ratio of the areas as well, right? Yeah. So it's just use what the midpoint and the bisectors. So midpoints just dividing the area into 1 to 2, right? The smaller one and the bigger one. And depending on the altitude here, you could also do like a 1 and a 1. For example, if this is midpoint here, this is midpoints. Or whatever, in the triangle like this. So if you have, you could do all kinds of things, right? So for example, this area would be equal to this area, right? Because they share the same same altitude, but with the same base using the midpoint theorem, yes? So that's what the midpoint actually does. Okay, so this is a very clean solution, and he didn't even need to solve for x because it's unnecessary. Okay.
Yeah.
Very good. Let's start from the easy ones. We have a lot of ones. So let's start from number 21. Okay. And there are problems which some people solved it. Let's see who was the student who solved the number 20 in the updated file. I think it was, is that you, Kieran? Did you send me something about number 20?
No.
Not about you? Not you? Who else? Daniel. You sent me something, right?
Yeah.
Yeah. So do you want to see the solution?
Okay.
Okay, so the number 20, Matthew, can you solve that problem again?
Yeah.
To
Sure.
the class. I mean, we discussed this in the last lecture, but other students didn't see it. So you can solve that?
Yeah, I can.
Yep, go ahead. Let me draw the picture for you, okay?
Okay, thank you.
It's easier for me to draw here. You have this line here. Actually, and there's another one. So let's draw this line here. So this is from the tangent point, and this line is the diameter, right? So this is the diameter. Why this is so, it's not in correct position here. So what happens? Give me 1 second. Okay, so I want to do this right. This is better. Okay, so this point here is, this is X, right? Here's Y, yes. And then we draw a line there. So this part is 1, this part is 5, and this part is 2. Is that right, Matthew?
Yeah.
Okay,
Is
so
is it
yeah.
answer 5 root 42 of root 6?
Ask Matthew, I forgot the answers.
Wait, answer did you get?
I got 5 root 42 over 6.
Yeah, that's what I got.
Oh,
Okay.
so this is what, the C? This is C, right?
Yeah. Oh no, C is on there. Yeah.
Oh, okay. So C is there.
No,
Sorry.
it's on Y. It's on the line of Y. It's on this
Okay. Now, what is this point then?
A.
This is A.
And
Then this is what?
E. The intersection of those two chords is E.
Then
And that's pretty much it.
E here.
Yeah.
E here, maybe. Let's give a point here called Z.
Yeah.
Okay, you can start from here.
Okay.
Oh,
So,
actually, the radius of each, the diameter of each is given, right? So xy equal to 10, is that right?
Yeah.
And the zy is what?
6.
6. So these are diameters. Diameters. Right. Okay. Go ahead.
Okay. So they were given this diagram and we want to find CY. So then the first thing we should note is that since they give us the diameters, that means this radius of circle ZY is going to be 5, and then the radius of ZY is going to be 3. So then what I did is that I put the center of circle ZY and I called it O1. And I drew the radius from O1 to C. And then I picked another point called O2, and that would be the center of ZY. And then I drew a radius from here to E. So one thing you can see is that these triangles, we have similar triangles. So triangle EYO2 is going to be similar to triangle CYO1. And we can see this because like they have both the radiuses are parallel to each other and they all share the same sides and angles because we have segment CY and then diameter XY. And then since both triangles share the same side and same angle, they're going to be the same. So I called ZY.
Did you explain why the angles are the same? Or
Yeah. So like they all share the same angle. So like both triangles share angle, the arc CYX.
this one you mean?
Yes.
Okay, so this one is equal, but why the other ones are the same? Yeah, you said they are parallel, but why they are parallel? If they are parallel, of course you are right.
Maybe I should draw. Oh wait, maybe I should draw. Let me erase that. Maybe I shouldn't do that.
Yeah, I told you that you should not use this term. There is no need to use this.
Yeah, I know. Now I know what you mean.
Okay.
So let's draw from C to X, and then let's draw from E to Z.
I mean, what you said was correct. Okay, it's just that you need to prove similarly. You have to draw this too in order to say they are the same.
Yeah. So then that means by the inscribed angle theorem, that means angle XCY has to be a 90-degree angle. And then that also angle ZEY is also going to be a 90-degree angle as well. And then this shows that they're both parallel, which means they're both going to be similar. So now that we know triangle EYZ is going to be similar to triangle CYX. So that means if we wanted to find the ratio, that means EY, over yz is going to be equal to cy over yx. And then I'm just going to write it all over here on the left-hand side. So we know that if we, I just called EYZ, so that way we can see the relationship between EY and CY. So then we have Z over, and then since we know YZ is 6, so Z over 6 is going to be equal to CY over 10. So then this means CY is just 5/3 of Z.
Did you? Okay, you use Z for EY. Okay, that's fine. Mhm.
So then that means, which means CE must be 2/3 of Z.
Well, I hate the way you write the fractions like this. It's very easy to cause confusions.
Oh yeah, I'm sorry.
Yeah, so what you should write as, I would write this as 5Z over 3.
Okay.
Okay. Yeah, this is a little bit better for this.
So that means CE is going to be 2Z over 3. And then we can use the power points for like chords CY and AB since they both intersect at E. So then this means CE times EY equals AE times EB. So then if we just plug everything in, we get 2, we get 2Z over 3 times Z. And then AE is 1, and then EB is just ED plus DB, which is 7. So then that means we get 2/3 Z squared is equal to 7, which then becomes Z squared is equal to 21 over 3, which, and then, no, 2, sorry. 23 over 2, 21 over 2. And then if we simplify this, if we take the square root, it's just the square root of 21 over 2, which is just equal to the square root of 21 over root 2, which is just equal to 2 root 42 over. Oh, sorry.
Are you okay?
So then since we know CY is just 5/3 of Z, it's just equal to CY is just equal to 5/3 Z, which is just equal to 5/3 times root 42 over 2, which gives us our answer, 5 root 42 over 6.
You guys can see that everything we used here is just a simple application of angle bisector theorem and power point. Okay, so in other words, it's a kind of problem which mixed a mixture of questions, mixture the problems, mixture of angle bisector, power point, and the circle properties. So basically, it's you don't expect to go into math Olympiads. You don't see there's only one technique there. It has to be all kinds of technique involved, mixed together. Okay, so you need to find the relations among them. How many people solved this besides Daniel and Matthew? Anyone else who solved this? William, did you solve this?
I tried, but no.
Rebecca, did you solve this?
I also tried, but I couldn't get to the final answer.
Yeah, do you understand this solution here?
Yeah.
Yeah, okay, so you know it's now it should open your mind that you have to mix things together. And so once we learn the theorems one by one, then you can see that a lot of things are going to mix together. All right, so we're going to move on to number 21. It's a very simple problem, but let's see who can solve this. Anyone is welcome to discuss this question. You guys are solving questions, right? You guys are solving problems, right?
I could do
I
it.
could solve it.
Let's see, I want Rebecca to try it. first?
Okay.
Or picture?
Okay, so the picture I drew was this. Sorry, my computer's being a little weird.
It's okay. Do you need me to draw it for you, or
I think I'm fine.
you call this X and Y, right? So you call this is X and Y. Yeah, that's fine.
Yeah.
So this point here is a D.
Yeah, I meant to draw that.
This is a D.
Yeah. And so since angle A is being bisected, it's just nice to like have that drawing. So based on the angle bisector theorem, we could solve for AC, which is x over 2 equals y over 5. And you get x equals 2y over 5 once you solve it. And basically you get AB equals 2/5 AC. And since AC equals 10 stated in the question, you could just plug in the values. So AB, we previously solved it as 2/5 AC plus AC equals 10. And once you solve it, you get AC equals 50 over 7. And we could also use the same equation to solve for AB as well. So you get, when plugging in the values, you get 50 over 7 plus AB equals 10. Once you solve for AB, you get AB equals 20 over 7. So those are your two values.
That's right. Very good. Very good. So you see that. Do you agree that without the angle bisector theorem will be difficult? Do you agree?
Yeah.
So we do need this theorem. You guys know the theorem, don't you? Did you guys know the theorem before you come to this class? It's used in math counts quite a bit. And so if you don't know this and you did math counts, that's kind of a joke. Do you agree? Because if you the math counts uses this quite a bit. If you see one of the like number 25, which is from state math counts. Okay, we're gonna see that. Okay, very good. 21 and 22. Anyone? William, can you solve 22?
Yeah.
Go ahead.
So here we have a diagram that kind of looks like this. Oh.
Where is it? Yeah.
So here we have
It's
A.
fine.
And C. So AB equals 20. And AC equals 10. So here we have this bisector of angle BAC. And it ends here at D. We know that B, so actually it's P. So we know that BP equals 20 times root 3 all over 3. And CP equals 10 times root 3 over 3.
Oh, actually, no. So this is number 20, 20 what? 22? 22
Yeah.
is another right angle there, right?
No, it isn't.
Not a right angle. So you should draw it carefully. So I thought it was the next picture. So you should draw it like this. Okay. This is yes.
So basically we can observe that AC over AB equals CP over BP, which all equals 1 over 2. So since they have the same ratio, we can see that AP is an angle bisector of BAC. So
Right, that's the point.
BAP minus CAP equals 0 because the angles are the same.
Right. Very good. So the answer is 0, right?
Yeah.
Very good. So you know what? Because there is only one line in on this so-called sevin. There is only one sevin that would be angle bisector. You cannot have two different point which give you the same ratio. So that's if the ratio is the same, AC over AB equal to CP over BP, then that AP must be the angle bisector. Very good. Number 23. Anyone who can solve number 23? Yeah,
can.
please. Who is talking here? So
Grace.
Grace. Yeah, Grace. Okay, very good.
Okay, so number 23 is the in the figure angle C is 90 degrees. So yeah, and that's an angle bisector. So AC is square root 2 and this is D, and CD is 1, which means that this is square root 3. AD is square root 3. And so I made DBX, and I kind of just followed the angle bisector thing. So AD squared 3 is equal to this is the square root of equals square root 2x squared plus 4x.
I don't follow you. I don't quite follow you. So what you're doing here? So
Okay.
you should tell us this one first, right? So this one is
Sorry.
2 plus 2 plus 1 plus x only squared then square root. Is that what you're saying? Is that what
Yeah.
you're using?
Uh-huh.
Yeah, you have to first of all find the hypotenuse AB.
Yeah.
Using the Pythagorean theorem, then you use angle bisector. You should remind us what the angle bisector theorem is, right?
Uh-huh. Yeah.
So AD squared equal to what?
AD squared is 3.
No?
Oh, sorry. Yeah, equal to AB times AC minus BD times DC.
Right, CD and DB, yes. And using this, so then you compute this. So how do you get, so the AB times, so AB is the square root though, AC is square root 2.
Mm.
So how do you get this? I mean, you have to show us how you get it.
Yeah, sorry. So this is 1 plus x, and 1 plus x squared is 1 plus 2x plus x squared. And
Write it down. Write down what you are saying. Yeah, write down. We don't follow you.
yeah, so this is 1 plus x, and that squared is equal to, I'm gonna switch it, x squared plus 2x plus 1. And this is square root 2, and that squared is 2. So I multiplied this. I multiplied this by 2, which so I got 2x squared plus.
Hold on. You multiply this by 2. Why do you multiply this by 2?
Because sorry. A squared plus b squared equals c squared. Oh, sorry. I added 2. Sorry about that.
Oh, I see.
A squared plus b
So
squared.
that's this one. Yes.
Yeah, so 2 plus 1. So yeah, and then that square, and then that square root is just the square root of that. And
How do you get 2x squared there?
because sorry, I'm gonna scribble this out. X squared plus 2x plus 1, and then I added 2, so plus 3. And for the problem, AD squared equals.
Hold on. So you do this. So you mean this one, this side, hypotenuse here, is the square root of x squared plus 2x plus 3, yes? Okay, so you don't need to write this here. And then what you do, you're using what are you using here?
I'm using this, so AB times AC, so the square root of this times the square root of 2 equals this.
Okay, then you need to minus, right?
Yeah.
Minus CT, so you need to subtract x here. Okay, go ahead.
Minus
Yeah,
x
write down
times.
the x, yes.
Yeah.
Very good. Yeah,
Yeah.
so yeah, you just follow this. Okay, very good.
And then I just moved this x here, so 3 plus x equals square root of 2x squared plus 4x plus 6. And yeah, I kind of just solved for x. And x in this case, so yeah, just 9 plus 6x is equal to, and 9 plus 6x is equal to, sorry, plus 6x plus x squared equals 2x squared plus 4x plus 6, and then I solved for x. In this case, x is equal to either positive 3 or negative 1 because I got just x minus 3 times x plus 1 equals 0, but since this is a measurement, x has to equal 3. Yeah, and so I just found the area using that.
Right. You see, there's a. Let's see. If you use you see here, if you use x on this side, it's a little easier. You see here. So this is 1. This is if you use this as x, you see what happens. And this side is x over square root 2, agree? Because the angle bisects the theorem.
Yeah.
And then if you use this is square root 3, right? So then you get 3 equal to square root 2 times x minus x over square root 2. Don't you think this is a little easier?
Yeah.
So then you would get 3 root 2 equal to just x. So this part. So therefore, this one is equal to just 3 here. Okay,
Mm-hmm.
that's it.
Oh, yeah.
So it depends on how you do it. I mean, you are using the Pythagorean theorem, but if you do not use Pythagorean theorem, rather use angle bisect theorem, it's much quicker to solve. Okay, but I did use this one. I did use this as so it's a little bit easier for you to solve. Okay, very good. It doesn't matter how you solve it. The key is that you can solve it. That's the thing. Number 24 is a fairly simple problem. Can anyone? Let's compare the answer. How about that? What is your answer for number 24?
7/2.
7/2.
7/2.
Yeah, everybody get that? Yeah, everybody should be able. Okay, number 25 is the one which we like to see, which is a math concept problem. And that's the one you're supposed to solve, okay, next year. Hopefully, we are able to do math concept next year, okay? So so right now everything is screwed up. So hopefully next year everything will come back, all right? So, but you see, you are right now is only 7th or 8th graders, right? So there are some people who are 6th graders. No 9th graders, right? Besides Matthew, okay? So everybody is 7 or 8, is that right? Is that right? Any other students who are 9th graders here? Anyway, so look beyond your high school years, okay? So what we're doing here is prepare for the future of you, okay? So they said that, you know, US is gonna be behind China for you know, for the future, the artificial intelligence, all this scientific field is because we are weak in math. That's what people are talking about. And then are we really weak in math? If you keep doing like this, you're gonna be super strong in math. And I guarantee that you're gonna be, before you go to college, okay, you're gonna be better than most of the Chinese graduates for sure. Because the, you know, this year we do algebra. Next year we do calculus. You know, when when are the students there doing calculus? It has to be last year of their high school years. So you know what? We're gonna finish your calculus next year. That means your math is already at the very high level of the you know, is comparing to any students in the world next year. And then we do math Olympiad, which is training you how to think, how to tackle the very difficult questions. And so right now we are doing very basic geometry, but later on you're gonna see a lot of other techniques in number theory, combo, and polynomial theory, and everything, all right? So you guys are going to learn a huge amount of math. And then before you go to college, you are going to be really, once you go to college, you will feel like your math is better than 99.9% of your peers. So there, in the future, you're going to be the leaders in artificial intelligence, in the big data, in the space exploration, in all these kind of field. Okay, so look beyond your just high school and elementary math concepts, these kind of things. It's not your final goal. Your final goal is understanding mathematics, mastering the basic techniques, mastering the advanced techniques, and then preparing yourself into the, you know, for the future challenges, all right? So look beyond that. Okay, let's do number 25. Who solved the number? Anyone solved the number 25?
I can.
I like to see other people. Anyone else can do this? Caroline, Brian, and Michelle, Justin, Emily, and who else? Jennifer, is Jennifer here? Kenan, anyone? Allison? Yeah.
Am I allowed to do it? Or
Who is that?
it's me, Sai.
Oh, sure, you can try. Yes. Yeah, I really prefer the the more freshman students to try. But let's see if anyone from freshman would like to try first, because you've seen this solution already, Sai. So I don't want you to, just talk about something you already knew. William, how about you? Anyone else? The person I talked, Justin, Milan, Matthew, Du, Omar, Tanish, Anvi, anyone besides William? William
Yeah.
is already who?
Yeah, I solved it, but I did just do a problem, so I don't know if.
Is that Grace again? Yeah,
Yeah.
you just solved it. Okay, very good. Thank you so much. I want William to try this then. Okay, so you no one else to try.
So here we have a right triangle ABC with the right angle at C.
Yeah, so very good. Yes.
Oh, sorry. Oh. C. So we have an altitude to draw into, oh, okay, thank you. So we have an altitude drawn to AB.
Yeah, let me draw this for you, okay?
Okay.
So I can draw this faster. So this is an angle bisector here. Okay, so this point is E, this point is D, and the side lengths here are 724, and we need to find ED.
So we can start by finding the length of altitude CD using two different ways to find the area of ABC. So since this is already a right triangle, we can use the form, we can just solve its area in one way, which is 1/2 times 7 times 24. Another way we can solve this is 1/2 times the base AB times altitude CD times 1/2. And we got the length of AB using Pythagorean theorem. So we'll find that CD equals 7 times 24 over 25.
This is very good, using using this using area formula, and that's very good. Okay.
So from here we can use the Pythagorean theorem on triangle BCD to find that BD equals 7 squared over 25. So from here, we can subtract 25 minus the length of BD to find that AD equals 2 to the 6th power times 3 squared all over 5 squared. So we can let ED equal X. Then CE would obviously equal 7 times 24 over 25 minus X. So by the angle bisector theorem, AD over AC equals D times equals DE over CE. So we can substitute the lengths that we calculated into this equation here to solve for x.
So you are doing what? X times. So how do you mark
X.
this out?
So I got x over x divided by 7 times 3 times 2 to the third power over 25 minus x. And that is equivalent to 2 to the 6th power times 3 squared over 5 squared all over 24. So that's the ratio AD over AC.
This ratio is 24 over 25, is that right?
Yeah.
Over this, yes?
Yeah.
So you cancel that out, it's just 24 over 25. So you can solve for x here.
Mm-hmm. And then we can get x equals 576 over 175.
So what's the top?
576 over 175.
175. Is that correct? Let's see. Where's my answer? Yeah, this is actually, where's my answer? So 576, which is correct. Give me 1 second. Yeah, this is correct. Okay. So, in other words, we are, I mean, there's only minor issue here that, you know, William's using a very nice method to solve for this. And he uses an area formula to solve for this. You could solve this differently. William, what would you solve if you don't use area formula for this part?
In this case, we might have to use a system of equations involving the Pythagorean theorem.
No. Remember that you learned the so-called, yeah?
Oh, right. Projection theorem.
Say it again?
Could we use the projection theorem?
Yeah, you could use a projection theorem. So like ED times 25, right? ED times BA equal to 7 squared. So therefore BD equal to what? 7 squared over 25. Do you agree? So this is a projection theorem. So you see you have to use a Pythagorean theorem to do this, but I just do it with a simple, solutions right away. It's much quicker. Okay. For general math Olympiad, doesn't matter, but for the math count, it matters because it's faster. Math count is all about the speed and accuracy.
You could also just see similarities.
Yeah, similarity is the projection theorem.
No, I mean, like, you know that CDA is going to be a 745-25 triangle.
I know. These projection theorem coming from this similar triangles. So it's just that it's faster.
I'm just saying that all you really need is just CD, and then you can just find ED from the angle bisector theorem.
From CD, yeah. Okay, so you are saying we don't need this.
Not really, yeah.
But you need this though.
No, you just need CD.
How do you use CD without using this thing here? Without using AD? How do you get?
Because ABC is already a right triangle, right?
Right.
And then you draw an altitude to D, and then you just have similar triangles that are similar. So like
Well,
triangle.
then you have to still trace similar triangles. It's the same thing. I mean, right now, everything is simple. You see, like this equality is easy, right? And this equation here is easy.
Yeah,
Agree?
mine just pretty much like since it's
That's fine. Okay, so you can use any method here. So I'm not saying that you cannot use other method to solve, like William solved it very quickly by using the area formula, which is, you can use all kinds of method here. So what I'm saying here is this, don't forget the projection theorem. This one is a powerful point, actually, the projection theorem. You will see that why the PowerPoint is so useful, because it's so quick to get answers. All right, so let's see the number 20. Where's the number 26? 26 is a trivial problem, right? Is it? Okay, so number 26 is a trivial problem. Oh, I'm sorry. Number 6 is a IMO problem. That's the one which I don't want you guys to solve at this point.
Yesterday, my mom showed me how to solve it. I can
Well,
show
look,
you guys.
you don't supposed to, you are not supposed to ask your mom for this. Okay, so you could, but that's only when you exhaust your own solutions. So what you want to do is that you try to think of this yourself. Okay, so I don't want you to solve this yet. Okay, so I just leave this here for you to, for some people to challenge yourself and thinking through it. It's not that hard problem, but you know, it's user angle bisector theorem. Very good. I think Matthew solved it too, right?
Yeah, I think so.
So okay, so Edward, so you try to understand this, and then eventually we'll need you to help us, okay? And
Okay.
number 27, anyone who solved the number 27?
I did.
Okay, I want to see. Okay, so who was the first one said?
Me.
I don't know who. Sorry.
Edward.
Edward, okay. Yeah, you can help us. Yeah, you should try to solve problems now. Yes, go ahead.
Because of the angle bisector theorem, AF over FD equals AB over BD. And
You need to draw pictures. You need to draw pictures. You want me to draw a picture for you? So like
okay.
this is a 6, 7, and 8. So you have this, which is, what is the E? What is the point of E here?
E is,
E is a midpoint, right?
what?
Is E a midpoint?
No, E is an angle. EB is an angle bisector.
It's an angle bisector, sorry. Okay, it's an angle bisector. And AD is also angle bisector, right?
Yeah.
Okay, you can solve from here.
Okay. AF over FD is equal to AB over BD because BF is the angle bisector and
Yeah.
BD, no, AB over BD is equal to.
Write everything down. You don't just talk without writing things down. So AF over FD equal to what? Equal to
AB over BD.
AB over BD, yes.
Yeah.
And
then you can find You can find BD using the angle bisector theorem.
How do you find that?
6 over BD equals 8 over DC, so BD is 3/4 DC.
6 over BD equal to 8 over
Oh,
7 minus BD. So you said BD equal to what?
BD equals to 3.
You solved this as a 3?
Yeah.
3 is correct. Yes, 3 is correct. So you get a 2 equal to 2, which is good. And then?
And then AB over BD
This
is equal to 6 over 3.
Yeah. So it's going to be 6 over 3, which is a 2. Yes.
Yeah.
It's a 2 to 1. That's all you need, right? So the answer is a 2 to 1. Yes. Okay. So number 28. Did anyone solve for number 28? Matthew, did you solve this? Does this require a lot more than we have here? I didn't have a chance to look at it.
No. It's you can just solve it.
Without using anything, right?
Yeah, pretty much. You just
Okay,
need-
so let's see. Who can solve this? Anyone who can solve this?
I can.
Okay, William. Anyone else? I like to see
can.
people. Who? Edward, right?
Yeah.
Yeah, anyone else? Michelle, can you solve this? Alison, can you solve this? Andy? Brian? Caroline? Charles? Daniel? And okay, so Emily? Grace? Justin? Okay, Edward, can you?
Yeah.
Yeah, go ahead.
Um.
So let me draw the picture for you. Okay, so it's gonna be A here, B here, and C here, and then you have what? D is the midpoint, right?
Yeah. And then E.
Have the angle bisector here, E. So this one is angle bisector. So AE is the angle bisector. Angle BAC, right?
Yeah.
So then you need to figure out the area of this thing. Yes, go ahead, show us.
So, the height of the triangle is 12.
Because this is a 13, 15, and 14, right?
14. Yeah.
Why the height is that?
You can use Herrons formula and then.
Whoa. Does everybody? Do we all know Herrons formula?
Yeah, it's square root S.
No. I mean, I'm asking everybody. We haven't done this yet. How many people know how to prove this? Edward, do you know how to prove Herrons formula?
No.
William, do you know how to prove Herrons formula? After you guys discuss this, I will prove it for you. It's very simple. So the Herrons formula is this. So the area of the triangle ABC is equal to square root of S minus A, S minus B, S minus C here. S is the semi-perimeter of the triangle. ABC are the sides. Okay, so this A is equal to 14 and B equal to 13 and let's say 15 and C equal to 13. Agree? So ABC are the side length of the of the sides opposite to the angle. So like A is opposite to the angle A here. You understand? All right, so if you use this, then the area here is what? 84, right? So this is as a side, this parameter is 27, 32, it's a 16, yes? No, sorry, is that 16? No, not 16. So this is half of 14, 15, and 13. So it's going to be 20. So this is 21. Yes. You agree? And so therefore, this area is square root of 21 times 7, 8, and 6. So therefore, it's 80, 84. Yes. So that's the area of the triangle. And the area is 1/2 of a base times base is 14 times height. So therefore the height here is, so the height is what? The height here is what?
12.
What is that?
12.
Well, okay, thank you. So that's the how you find the height. Okay, so the height here is 12. Okay, you can go from here, and I will prove this formula for you in a minute. Okay, go ahead. You
The
can write
area-
everything here. Yeah, you can write the area. Area is 84, right?
Yeah.
Okay, go ahead.
I'm on a computer, so I can only type the things.
Oh, okay, you can talk, and then I can write it for you.
Oh. The area of AED would be ED times 12 divided by 2.
It's gonna be, say it again, 1/2 of ED.
ED times 12.
Right, what is ED then?
ED is equal to DB minus BE, and DE is 7 because it's the midpoint.
BD minus BE, yes. So
Yeah.
BD is 7 minus, you need to use angle bisector theorem, right?
Yeah.
So the BE times 14 minus BE, not times, angle bisector theorem should be BE over 14 minus BE is equal to 13 over 15. Is that right?
Yeah.
Okay, then you can solve for this. You get a 15 BE equal to 14 times 13 minus 13 times BE. Agree? So you get the 28 BE equal to 14 times 13. So therefore BE equal to 28 here. That's going to be 13 over 2. Is that right?
Yeah.
Okay, so therefore you get BE equal to this. So BE, so it's going to be 13 over 2. And therefore it's 1/2, yes? That's ED. And therefore using this, you get 3. Is that what you're saying?
Yeah.
Very good. Yeah, very good. So this is Edward's solution. Do you guys know that you do need the Herrons formula though, right? Unfortunately. So we'll solve the rest of the problem next time. We still have like 29 need to be solved. 28. Is 28 need to be, oh, we already, did we do number 28? No, we didn't, right? So
we just did number 28.
We already did. Oh, this is 28. Sorry. So this is 28. Okay. So number 29 is okay. So we maybe we should just solve 29 and 31. Those were, we already solved the 30, right? Let's finish them today, okay? So let's finish this. 29, anyone who can solve 29? Do you have any questions about this? Can I spend a little time proving this theorem for you? Edward, do you
Sure.
need the,
Yeah.
can I, Edward?
Yeah.
Okay, so we do this proof. The proof is, you just use, all you use is what? Right triangles and, you know,
Oh,
different squares, that's all.
I think my geometry teacher in LPS proved it to us. And
How
you
did
have
they,
to,
how did he prove? Or how did she?
you draw an altitude from A to BC, and then
Yes.
you find the altitude in terms of the sides, and then get the area, and then factor it into something that involves P. I mean,
Yeah, so yeah, so yes, it's basically just do the different squares. That's all you needed. Let me call this side as x here. Call this side as a minus x. Okay, is that okay?
yeah.
Now what we do is that you get BD, or rather say c square minus x squared equal to h squared. Do you agree?
Yeah.
Yes. Now h squared is also equal to what? B squared minus a minus
A
x
minus
squared.
x squared.
Right. So you see the altitude is important because it's a bridge connecting two right triangles. That's why it's important, the altitude. So in the triangle, the most important line is the altitude, okay? So then you get c squared minus x squared equal to negative a squared, and then b squared minus a squared, then plus 2ax plus x minus x squared, agree? And then the x squared canceled. So therefore you get x equal to, this gives you h equal to of c squared minus x squared. Now x squared is this quantity. You all see this? You all see this step? It was good. Okay, so then let's rationalize the denominator here. It's a 2a here. The top is 4a squared c squared minus a squared plus c squared minus b squared squared. Now we hate this formula because it does not what? It's not symmetric.
Easy to remember.
It's hard to remember. But let's write the area. So S equal to, I mean the not S here. The area of the triangle ABC is equal to 1/2 of A times H, okay? Which is, cancel this, so you get a 1/4 of square root of the inside here. Inside here, let's expand it. We know a squared plus c squared minus b squared squared. How do you expand this, Edward?
Using the multinomial theorem.
Right.
So
A to the 4, e to the 4, c to the 4, then?
Subtract 2b squared c squared.
Right, that's a plus 2a squared c squared minus 2a squared c b squared minus 2c squared b squared. Do you agree?
Yeah.
Okay, so if you use this, then subtract it from 4a squared c squared, then you get twice of a squared b squared plus a squared c squared plus b squared c squared, then minus a to the 4 minus b to the 4 minus c to the 4. Now this formula is good. Why?
Wait,
yeah.
Shouldn't there also be a c squared?
No, this is c to the 4 here. So why it's good? It's a symmetric in ABC. Do you agree?
Yeah.
Yeah, so you can permute ABC in any order, but the formula doesn't change, which means it's easier to remember this. So you guys should remember there's a different formula here. Why you need this formula? Well, sometimes you could involve with a triangle like this, right? Square 2, square root of 5, and the square root of 6. How do you use Herrons formula for this formula, for this triangle? That'd be hard. Do you agree?
Yeah.
Yeah, so you don't want to use this. Instead, you want to use this formula instead. Make sense to you?
Yeah.
Yeah. Okay, so, but this one doesn't lead to Herrons formula. So how do I go from here to Herrons formula instead? So Herrons formula is just going from here to this. So we're going to rewrite this as 1/2 of 2a. So we use the different squares. So you get this is square, right?
Oh, yeah.
So you get the 2ac plus a square plus c square minus b square, and then
2a.
2ac minus a square minus c square plus b square. Do you agree?
Yeah.
And that you can rewrite it as, let me put a 1 over 2a here. Then the top here is this. And the inside here, you see it's a plus c quantity squared minus b square. And here is b square minus a minus c square. Do you agree? So you
Yeah.
complete square again. And that you can rewrite this as just a plus c plus b times a plus c minus b. Then this is a b plus a minus c, and b minus a plus c. Do you agree?
Yeah.
Yes. So let's do the area formula. So the area of the triangle equal to 1/2 of a times h, which is 1/4 of square root of a plus b plus c, a plus c minus b, b plus a minus c, b plus c minus a there, right? Agree? Let's push the 1/4 inside, give a 1/2 to each one. So you get a plus b plus c over 2. 1/2 of a plus c minus b. Then 1/2 of b plus a minus c. Then times 1/2 of b plus c minus a. Agree? Then you notice that that's equal to the s. S is a semi-perimeter. This is s. And then this one is s minus b.
And then
This
s
one is
minus
s minus c, s minus a. Do you all agree?
yeah.
Okay. So all these, so this is the Herrons formula. We proved it. Okay. So not only we proved Herrons formula, we have an intermediate value. We have an intermediate formula here, which is very useful sometimes. Because when you deal with a triangle like this, then if you use Herrons formula, it's going to be, you have to rewind it, right? From this Herrons formula, go back to the different squares. And that's going to be a lot of derivations. But instead, if you use this formula here, you can find the area right away. Make sense to you? Okay, so, but I do want to prove a couple more theorems before we end this class. So we still have a few problems left out. We're going to do that next time, okay? Is that okay?
Okay.
A couple more problems. We're going to finish the rest of the problems next time. But I do want to lecture a few more problems here, which is, let's see, what are the theorems I want to do? So, one second. Basic geometry theorems. Okay, so maybe we just do the concyclicity. Yeah, concyclicity probably is better. Yes, let's do the concyclicity. All right, so as we promised last time that, first of all, the following, so this is theorem, okay? So the following are equivalent. One is that the points, or rather say the convex quadrilateral ABCD is cyclic. Or we say that the points A, B, C, D are concyclic. So what that means is that you have a circle here, you have 4 points on that, A here, then B here, and C here, and D here. So we write ABCDs in that order, okay? ABCD is a quadrilateral. Okay, so that's the first definition of concyclicity. Second is this, then angle A plus angle C equal to 180, or angle B plus angle D is also 180. You just need a pair of opposite angles adding up to 180 degrees. That will force the quadrilateral to be cyclic. Okay, so sometimes we say that, i.e., the sum of opposite angles, rather say this, the opposite angles are supplementary. Okay, and 3 is that, so the angle ACB equal to the angle ADB, or any other pair of base angles. So this, I just made up this name here. Base angles means this. ACB, that's one base angle. Another one is ADB, another base angle. So these 2 angles are the base angles we are talking about. You could also have different base angles. You could have this angle equal to this angle, or this angle equal to this angle, or this angle equal to this angle. Agree? So any pair of this are called base angles, because a pair of base angles, because we don't have a good name for that. Okay, so you just see that these 2 letters are the same, and this C and D are in the middle. Make sense?
Wait, what exactly does like the third part mean for those base angles?
I told you that it's just because if they are cyclic, that means what? That means that these 2 inscribed angles are the same, right?
Yeah.
So in other words, this inscribed angle equal to this inscribed angle. If it's a cyclic, they are the same. So this theorem says that conversely, if they are the same, you have a quadrilateral like this, right? If this angle equal to this angle, you know these 4 points must be on the same circle. Does that make sense to you?
Yeah, because they intercept the same arc.
Yeah. So no, the point is that we don't have a circle yet. All right.
Oh.
But the theorem says that if these 2 angles are the same, then these 4 points must be on the same circle. And the next one is interesting. That is, that's the next one. Okay, next one is interesting. That is the AC times, let me do it this way. AB times CD plus AD times BC equal to AC times BD. This theorem is called the Ptolemy's theorem. Ptolemy, okay? So this term is very non-trivial because you are interpreting the geometric properties in terms of the algebraic properties, right? So A, B, C, D here. So if the sum of the, product of the opposite side is equal to the sum of the product of the opposite side equal to the product of the diagonals. Can you read this for me? Edward, can you repeat the sentence I just said?
AB times
No. Use plain English.
Oh, the product of
The sum.
Oh, the sum of the products of the opposite sides is equal to the product of the diagonals.
Right. That's how you remember a theorem. Okay. And that becomes interesting. And actually, number 5, we add 1. Okay. So this is not in the notes. That is, if BA intersect with CD at P, okay, then PA times PB equal to PC or PD times PC. So basically, you want the power point to be true, okay? So in other words, if you have a P here, and like this, so this is, so even if you don't have the circle, as long as you have these ratio relations, so this is A, B, and this is D and C here. So if this condition is true, then this is, you do have the equality here. So they are on the same circle. And the conversely is just a power point theorem, right? So you know the power point theorem also kind of have a converse. Make sense to you? I have about 10 minutes. I can prove a few steps for you, few equivalences. Okay. Do you all understand the theorem? Do we all understand the theorem? Can I erase this whole thing?
Yeah.
I can, right? Okay, so what I'm gonna do is this. So we understand the properties, right? There are 5 properties. In the notes, we only have these 4 here, equivalences. And the last one is also coming from the PowerPoint theorem. We learned that, so we can use it. Okay, so here it is. I want to prove 1 implies 2. Now, if they are cyclic, right? If these points are cyclic, if this quadrilateral is cyclic, A, B, C, D, then by what? So if this is true, then by inscribed angle theorem, right? We have that angle A plus angle C equal to what?
180.
And angle B plus angle D is also 180 by inscribed angle theorem. Because these arc here, together with this arc is the whole 360-degree arc. But it's inscribed angle, so it has to be half of that. So you add this up, you do get 180. Okay, so this 1 implies 2 is clear. 1 implies 3 is also clear. Do you agree? So in that case, ACB, this angle here is equal to this angle. So this is also by inscribed angle theorem, yes?
Yeah.
Now, how do I prove the converse of this? Conversely, let's do 2 implies 1. How do I do 2 implies 1? Suppose I have a triangle like this. I mean a quadrilateral like this. This is A, this is B, C, and D, right? We know that these 2 angles add up to 180 degrees. Okay, so if angle A plus angle C equal to 180 degree, then what? How do I prove that these 4 points must be on the same circle?
Oh, Dr. G,
Yeah.
you can you know that angle B will be
Can you stop? I don't want you to. I mean, you know all this, okay? So just for you, just review, right? Yes.
Right. Yeah.
Yes. So unless other people cannot solve, otherwise I want you to just basically listen to it. I mean, you are welcome to do it when we need you. Anyone, the new students, freshmen, how do I prove that ABCD is cyclic if these two angles add up to 180 degrees? So for that, you need a circle, right? So first of all, we're looking for the triangle. Do we know that every single triangle has a circumcircle? Do we know this? Yes, we know this, right? Rebecca, do we know this? Every triangle has a circumcircle.
I'm not sure.
Or you don't know? Did you learn geometry? So what you do is this, you look at the perpendicular bisectors here. Okay. So these two perpendicular bisector of the sides, they intersect the point. Do you agree, Rebecca? Are you with me, Rebecca?
Yeah.
So you look at the two perpendicular bisector, you know what that means, right? These is just passing through the midpoints. You look at two perpendicular lines there to the sides.
Yeah.
Okay, so they're gonna intersect a point, but then what? If they are perpendicular bisector, that means what? This side equal to this one. We haven't done that yet, but we're gonna do that tomorrow. So this side equal to this side, right? So if you have a perpendicular bisector here, so this side equal to this side, then any point, if this right angle, then this side equal to this one by Pythagorean theorem, yes? You agree? Because this side is shared, yes? So by Pythagorean theorem, so this side equal to this side, and therefore this side equal to this side. Do you agree? Any point on the perpendicular bisector is equidistant to the 2 points, AB. Any point. Edward, do you understand this?
Yeah.
Rebecca, do you follow me?
Yeah.
So therefore, this side equal to this side, but this is also perpendicular bisector. That means this side equal to this side, yes? Which tells you this intersection here is equidistance. So this point called O here, O is equidistance from all the 3 vertices, right? You agree? And that is the circumradius. So if you draw a circle of radius r, then this is the circumcircle. Does it make sense to you now?
Yeah.
Every triangle has a circumcircle. Rebecca, I mean, you said you are not sure, but do you now understand?
Yeah.
Okay, so that's the point, that every triangle has a circumcircle. Okay, now we know every triangle has a circumcircle, so we can use what? We can draw a circumcircle here, agree? Now, we want to show that this circumcircle should also contain the C, yes? You agree? If not, so let's draw circumcircle of triangle ABC. I want to show, or ABD, okay? So ABD, then want to show that C is on. Okay, then these 4 points are on the same circle, right? Let's construct this. Let's extend. If not, say it's inside. Okay. Now, so C is here. C is here. Now, let's extend this point here to, so extend EC to a point C double prime on the circle, C prime, the circle, on the circle, okay? Extend it to here, C prime. Then connect what? Connect, extend, sorry. So extend here, right? We extend to C prime. Then we connect this D and C prime, right? So then, and then connect DC prime. So then, so this implies that A, B, C prime, D is cyclic, yes? And that implies the angle A plus angle C prime equal to 180 from the 1 implies 2, okay? Edward, are you with me?
Yeah.
Yeah, so what does that mean? But the angle C prime equal to what? Is the, so this angle here, angle C is what? Angle C is the, so this implies that angle C equal to angle C prime, yes?
Yeah.
Because we are assuming that, so assume that angle C plus angle A equal to 180. Yes? So we are talking about 3 implies 1. I mean, 2 implies 1. So we are assuming that this is true. Then we see that angle C equal to angle C prime, but that implies C must be equal to C prime. Do you agree?
Yeah.
This angle must be equal to this angle because this angle is the exterior. So since if not, angle C must be greater than angle C prime because the angle C is the exterior angle of this triangle CDC prime, right? Since angle C would be exterior angle, okay? Exterior angle of CDC prime, which is contradiction. Does it make sense to you? And that proves that 3 implies 1. And similarly, you can, I mean, 2 implies 1, right? So 2 implies 1. Similarly, can I just leave that to you? Okay. So similarly, one can prove that 3 implies 1 as well. So if you have 2 base angles are equal like this, then you can prove that the 4 points are on the same circle. So Edward, how do you prove 3 implies 1? Suppose AD, so if angle ADB equal to angle ACB, how do you prove that this is these 4 points on the same circle? How do you prove this?
Cause ADB is the inscribed angle of the chord AB, and ACB is also the inscribed chord.
Well, listen, we don't have a circle yet. 3 implies 1 says that suppose we don't have the circle. We don't even have the circle. We only have these 2 angles are equal. So how do I prove that these 4 points are on the same circle. That's what you need to prove. William,
Yeah.
you understand my question?
Yes.
So I just proved 2 implies 1. But I said similarly, you can prove 3 implies 1. What does similarly mean? What does this mean?
You can use like a similar way based on how we prove 2 implies.
What is a similar way?
You could also draw like another point and try and
Right, but you do again the circle of what? ABD, right? Because ABD always have a circle. Then you want to show C is on that. You agree?
Yeah.
So that's what we mean by similarity, similar proof. And then how do you prove it? Suppose C is inside. If C is outside, you can prove similarly. Okay, so suppose C is inside, then what? Then you can extend this to a C prime, agree? Suppose C is inside, right? The C prime. And then you connect this, and you connect this one here, agree? And then by the fact that these 4 points are on the same circles, then you get this angle equal to this angle. Then you would see this angle equal to this angle. But again, using the exterior angle argument that this CN must be equal to C prime. Can I leave that to you?
Yeah.
Yeah.
Okay. All right, so I proved 1 implies 2, 1 implies 3, just based on the inscribed angle theorem. But I also proved 2 implies 1 by using the method of unification. Suppose not, I can construct a circle containing 3 points. Then we want to prove that the last point must be coincide with a point on the same circle. And therefore, 3 implies 1 can also be proved similarly. Okay, it's left to you. You have to try it yourself. Okay, so if you don't prove theorems yourself, and you will never get to the level I expect. Okay. So so you can use those theorems. Next time I'll finish proving this theorem. Next time I'll prove the theorem. Finish the rest of them. It's going to be hard. Okay, but for now we're going to use them. Okay, so make sure you understand the Ptolemy's theorem. Make sure that you can use them. All right. So I'll give you examples that you can use it you can use this theorem to solve these problems. Okay, so we'll have a next set of problems. Okay, and that's all for today. And we're going to finish this theorem, but we're going to have another set of assignments on things related to angle bisectors, PowerPoint, and also Ptolemy's theorem as well. And I'll see you next week. Have a good day. Bye.
Bye.
Thank you.
Yep.
Thank you.
Bye-bye.
Bye. Thank you.